This is a little video to help you understand how to do mole conversions. I'm going to do about 5 or so of the 22. So given these 5 and then plus the ones that I did in class, you should have a pretty good start. So we'll start with this is number 9. I just went down the list a little bit. And by the way, the order on these is going to be different depending on, it's different every time you open up the application. So if you end up duplicating a couple, that's not a problem. That's okay. Don't duplicate 5. So the first question is, so what's the mass in 10 grams, in mass in grams of 10 moles of ammonia? So the number that you're given to start with is 10 moles of ammonia. So I'm going to write that down, 10 moles of ammonia. And again, I know that because it tells us that we have 10 moles right here. And remember the mole map we talked about in class. If you don't have that, take a picture of that right now with your phone so that you have it in front of you. So moles on the mole map are right in the middle. So you're starting with moles, so that means we're here on the mole map. The question says we want to go, what is the mass in grams? So that means we are going to the right over here to grams. So the way this map works is that anytime you're transitioning from moles to grams or from grams to moles, you're going to use the formula mass in some way. You will remember, I hope, that formula mass is what you get when you add up the formula weights on the periodic table. Going further, not relevant to this problem, but if I wanted to go from moles to particles, like atoms or molecules or formula units, then you will always use the 6.02 times 10 to the 23rd definition of the mole. That's how many things are in a mole. For the purposes of this little activity, they'll work out a little bit nicer if you just round this off to 6 times 10 to the 23rd. And then when you want to go from moles to liters or liters to moles, you'll have to use a 22.4 liter definition of the mole. This only applies to gases. All right, now moving on with this problem, we had 10 moles and we want to change to mass in grams. So I'm going to multiply. You'll remember me in class telling you that the words that are here, not the number, but the words, everything except the number, that's everything except the number, goes on the bottom of this conversion factor. So we'd have moles of NH3. The reason for that is we want to cancel these out. So moles divided by moles will equal 1, and that's cancellation like in math class when you have x times 2y over 3y. The y's cancel, and you end up with 2x over 3. All right, so the moles of NH3, and on top we're going to put what we're looking for, which is grams of NH3. Normally I just write G, but this time I'll be more precise. So now we need to know how many grams are equal to 1 mole. You may remember in class I told you that the number 1 always go with moles in this problem set. So we'll pull our periodic table out, turn it right side up, and you'll see that nitrogen has a mass of 14. You can see it right there. And hydrogen is over here, has a mass of 1. So since there's 1 nitrogen and 3 hydrogens, I'm really going to have 14 plus 1 times 3. So that gives us 17 grams. All right, so now we're finished setting up the problem because moles have canceled and we're left with grams of NH3, which is what the problem asks us to find. So all we have to do is the math. So you'll remember, I hope, that in math class, when you learned to multiply fractions, if you had something like 5 times 3/10, like that, you would multiply 5 times 3 to get 15. There's an invisible 1 down here. 1 times 10 is 10. Then you would have 15 divided by 10, which is 1.5. So in these problems, you multiply everything across the top and divide by everything across the bottom. So in this problem, I've got 10 times 17 across the top. There's an invisible 1 right here. So 10 times 17 is 170. The unit that did not cancel is grams of NH3. And to check your work, you can go over here and see if you got it right. So you pick up your mouse and you click right there, and it's correct. All right, let's go down and do another problem. Let's do number, yeah, that was too easy. Let's do this, not that one. Not that one. These are all these two. I was going to try and find one that's a little more difficult. There aren't very many that are really super difficult, but this one's a little harder. All right, so here we go. So we'll do this one. So we have 15 grams of C2H6. I'll skip a line. I want you to fill out all these boxes, but 15 grams of C2H6, but it might make it a little easier to see if I do this. All right, 15 grams C2H6 times. All right, now you have to decide where you are on the mole map. So we have grams. We're trying to get to molecules. So think to yourself, am I here, 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 or there? 15 grams. Where are you? So you'd be here. So grams, I'm trying to get to molecules. Molecules way over here. So this is a two-step problem because along the way, in between grams and molecules, is moles. So we're going to change grams into moles and then change moles into molecules. So how many steps is that again? Grams to moles, moles to molecules. 2. When we go from grams to moles, we have to use the formula mass definition of the mole. When we go from moles to molecules, we have to use the 6 times 10 to the 23rd definition of the mole. Here we go. So remember in the previous problem, I reminded you that everything that is here goes on the bottom. So you're going to put grams of C2H6 on the bottom. Everything except the number, that is. And on the top, you put what you're looking for. In this, we're looking for molecules, but in this first step, we're looking for moles because we're going from grams to moles. So we're going to put moles on top. All right. The number 1 will always go with moles, and C2H6 has carbon, 2 of them, and hydrogen, 6 of them. So I'm going to look at carbon over here. You might be able to see that it is 12. It's kind of out of focus, but it's 12. And hydrogen is 1. We already talked about that. So I'm going to have 12 times 2 plus 1 times 6. 12 times 2 is 24. 1 times 6 is 6, so it's 24 plus 6, which is 30. So that's our first step. Second step. All the words that are here go on the bottom, so that's going to be moles of C2H6. On top, we put what we're looking for. In this case, it's molecules right here. Molecules. So we put molecules on top. So molecules is like it relates to moles in the same way that one egg relates to dozens of eggs. So one molecule, so you have a bunch of molecules to make a mole, you have a bunch of eggs to make a dozen. It's that kind of a relationship. So you put 1 with mole, we always use that in this set, and then we have to look at the definition to get from moles to molecules. We're going to use this number, and again, if you just round this off to 6, it'll make it work out nicer in terms of rounding. So 6 times 10 to the 23rd molecules. All right, now we have to put this into our computer, or our calculator. And there's a couple different ways to do that. I think I'll show you on an iPhone calculator. Then I'll show you also on the computer with a regular calculator. Okay, so you may recall I told you to multiply everything across the top and divide by everything that's on the bottom. So if we do that, we would have 15, so that'd be 15 times 6, then the EE key 23. So again, I mentioned in class, but if you weren't in class, instead of punching in times 10, you type in 6. Let's do that all again. So 6, and then EE 23. Whoops, I didn't look good. So let's go ahead and start fresh. So 15 times 6 EE 23. That gives you 9E24. So 9E24 really means 9 times 10 to the 24th power. All right, and we're going to divide that by 30 because that's on the bottom. There's an equal sign there. So divide that number by 30. There's also ones down here, but they don't change anything. So our final answer is 3e23, which means 3 times 10 to the 23rd. All right, is that the correct answer? That's an option. So yes. Now I'm going to show you how to type this in on a different calculator. Here it is again. So this one is has got a button on it called the EXP key. So let's do that. So I'd have 15. Is that where you can see the screen? 15 times 1, which I'm going to skip because 1 doesn't change anything, 6, and then down at the bottom there's an EXP key. EXP 23. So 6E23 means 6 times 10 to the 23rd. So on the top, you get an answer of 9 times 10 to the 24th. Then you have to divide by everything that's on the bottom, but the only number that's not 1 that's on the bottom is 30. Remember, there's an imaginary 1 there. So divide by 30. Divided by 30 equals, and you get 3 times 10 to the 23rd, or you can see a 3, if you look closely on this screen, times 10 to the 23rd. If you like this calculator and you have an Android phone, download a free app called Real Calculator. If you have an iPhone, there are some other apps, but you'll get used to using the EE key on this. So I just use the EE key on the iPhone. All right, so that was the second example. So another example. I'll go a little faster on this because this is taking a long time. I just go random, so I won't explain quite as much. So we have 3 molecules of water. Now remember, molecules are right here on a mole map. And we're trying to find, oh wait, I take it back. It doesn't say 3 molecules. You got to watch that. It says 3 moles of water. So I'm right here on the mole map, and I'm trying to get to molecules. So moles go into molecules. All right, so 3 moles. Moles on the bottom, all the words go on the bottom. Molecules on the top. 1 goes with moles. 6 times 10 to the 23rd molecules are equal to 1 mole. That number right there, because we're going from moles to molecules. So now we have to multiply things across the top, so we'd say 3 times 6 EXP 23 equals 1.8 times 10 to the 24th. And there's nothing on the bottom to divide by because that's an invisible 1, so it equals 1.8 times 10 to the 24th. Is that a choice? Oh look, it is a choice. All right, let's do another one. Now, how many molecules are in 10? We just did one kind of like that. Let's do this one. Okay, you have 40 grams of argon. So we have 40 grams of argon. All right, so where are we on the mole map? Well, we're right here. So we're grams, 40 grams of argon. We want to get to volume, so we're going to go from here to here and here to here. How many steps will that be? 2 steps. So whatever words are here, go down here, grams of argon. The first step was to go to moles. So we have moles of argon. The relationship, 1 to 40. And we wonder where that 40. Remember, when you're going from grams to moles, you use the formula mass definition. Argon is right here on the periodic table, and it says 39.95. So you need to use 40, not 39, because 39.9 rounds up to 40. So that's where I got 40. But since this is a 2-step problem, we're trying to get to volume. We'll go ahead and put moles on the bottom, liters on the top, because we're trying to find volume. The number 1 always goes with moles, and the liters would be 22.4 right here. There are 22.4 liters in 1 mole. So now I have, doing all the math, multiply everything on the top, remember the invisible 1, so 40 times 22.4 is 896. Then I'm going to divide by 40. which is 22.4. So a final answer would be 22.4 liters of argon. Please notice that the grams were here, so I put them down here to cancel. Moles were here, so I put them down here to cancel. Final answer, liters of argon. Now some of you may be sitting there thinking, man, we didn't really need to do all that because I knew that 40 divided by 40 was 1, because you could cancel those out too. And then your answer is just going to be 22.4. And if you want to think about it that way, that's fine. But you do need to show all the work. All right, so the answer 22.4, you see it's right, so you check your answer there. All right, I think that's probably enough for this video. I'm hoping that this makes some sense to you. If you were in 7th hour, you got to think back to the egg conversions that we did in class on Wednesday. So remember how we said if all the eggs in the universe weighed 0.5 pounds, this is kind of the same thing. So if I had 40 pounds of eggs, how many eggs would I have? If every egg in the universe weighed 0.5 pounds, you'd put pounds down here, because whatever words are here, we go down here, egg on top, and we said one egg weighs 0.5 pounds. So you would have 40 times 1, and then divide by 0.5. So that would be 80 eggs. So you could count 80 eggs without actually counting 80 eggs if all the eggs in the universe had the same weight. They don't. But atoms in the universe do. Or at least they have the same average weight. All right, so you can count by using weights. All right, I'll stop the video there. I'll get this posted for you.